So guys, let's discuss the problem Fightbots from Codechef Contest, and it is saying that Fightbots. It is saying that there are two players, Alice and Bob, and these both are having two robots, and Alice robot will start from 0 and 0, and Bob's robot will start from a coordinate that will be given to us, that is x and y, and there will be a number n will be given, and this will represent the number of times Alice can move its robot by one place, and she can make only these type of moves, means right, left, up and down, only by one unit. And we have to tell that if anyhow Bob can place, in any turn its robot at the same place where Alice's robot is present, then we have to say yes. And Bob will start from x and y, and he will try to place his robot on the place where Alice has placed its robot. But the twist is that for each and turn, both will have to make the move. They cannot, their robot cannot remain idle at any turn. The turns will start from Alice, and the first turn Alice will move the robot, then Bob will move, then again Alice, then Bob, like this. And at each turn we have to move the robot. Now the approach I have used here is like that. I have first calculated that after n moves, where Alice reaches by the string that is given to us, which is containing these letters. If suppose it is the starting point is 0 0, so if I find right, I will increase the, this is x coordinate, y coordinate, I will increase x y 1, x plus 1. In left I will decrease x y 1, in up I will increase y by 1, and in down I will decrease y by 1. Now in this way I will calculate the last position of Alice. Okay, so I am approaching this problem from the end. So considering the last position of Alice as the starting position of Bob. Suppose last position is xa ya for Alice. I am starting Bob from here, and I am seeing that if Bob is able to reach x and y, its original position, from this position, it is the same thing. If we try to reach xa ya from xy, or we try to reach xy from xa and ya, it is one and the same thing. So I am thinking it in that way, that Bob is initially starts from here, and he tries to reach its original position. So if Bob reaches his original position, then we can safely say that the answer to this problem is yes. If Bob is not able to reach his original position, then we'll we'll give output as no. And how I have done that, so see, there are n number of turns are n, and I have calculated that how much is the difference between xa, and this will be the Bob's coordinate initial. I will calculate the difference between them by doing the absolute difference. I will calculate absolute difference. By absolute difference I mean that I will subtract xa from x, and I will keep the positive value. So I will check how much difference is between this xa and x, and this ya and y. And let me again tell you, this is the final position of Alice, and this is the initial position of Bob. We are trying to move from Bob from a final position of Alice to its his initial position. All right. And the difference, suppose the difference is d, and will be total number of turns. The difference is d. If the number of turns are equal to the difference, then we can make it. in that number of turns we will reach there. So in this case we will return yes. Now how many conditions are possible there? There are three conditions: n is equals to d, and n is greater than d, and n is less than d. In this case, surely we can say that yes, Bob can reach his initial position when number of turns are less than the difference. So we need to cover this difference, and difference is the absolute difference between xa minus x plus ya minus y. This is our difference. We need to cover this. So if the number of turns are less, then we cannot make it out. So here we'll straight away say no. And we need to check here when n is greater than d, we have to check. So what we will do, we'll find remaining moves by doing how much n is greater than d. So in these number of turns we'll reach their d. Okay, so after consuming d operations out of n, so d is smaller, so something will remain. So after consuming d operations from n, we will reach there. We will reach Bob's initial position, but there is some remaining turns, and as I have told you earlier that we cannot remain still at any turn. We have to make movement, and here we need to see how this remaining moves will take us to answer. So suppose I have to there is only 3 moves remaining. All right, and I have reached the position which I need to reach, that is 1, 0. So if I try to use all these operations for increasing or decreasing at any coordinate x or y, I will come far from this point. So I need to remain closer to this point. So at any point I will increase it. Suppose I will make 2, 0, then again I will make 1, 0. So if I am having remaining differences and remaining number of moves as 3, and I am here 1, 0 where I should be present. And now let me tell you this again. I am at 1, 0, and I need to reach there only. This is my final position. I have reached here, but number of turns are remaining, then I am forced to make moves. So I will not go far away from this 1, 0. So I will go away and then come back also again. So there are 3 number of moves. The first move will be, suppose I make it 2, 0. Then again I will make it 1, 0. This is first move. This is second. And in the third move, I am only remaining with the option that I need to make a move, and I will not remain at this point where I want to remain. You see, if the number of moves are odd, then I cannot remain there. And if you are thinking the other way, that if we can roam around in other way, let me show you. So we cannot do like this also. I have made it 2, 0, then 3, 0. Now again I need 2 moves to come back to 1, 0. So I cannot increase only 1 if I am also increasing or decreasing again. So 2 moves will be need to increase or decrease. Then again I will need 2 more moves to come back to the original position. So I'm not going to do that. I will make a move and then undo that move. I will reach the original position. That is only the best option I have. But as the number of moves are 3, I am reached here. In the second move, I am remaining with the only option that I have to make a move. So I cannot come back again here. I will make it 1, 1 or anything, but I am not at the position where I am supposed to be. All right. So I will simply from there we can from this example we can draw conclusion that if this remainder is what odd, then we cannot make it. If it is even, then we can make it. See, 1 comma 1, 2 comma 0, then again 1 comma 0, then again 2 comma 0, then 1 comma 0. I have reached there. How many moves? 1 2 3 4. And you see, in 2 moves also I am there, in next 2 moves I am there. So if there are even number of moves are remaining, then I will definitely make it, and our answer will be true in that case. Now let me show you this. So we initially we were having 3 options, this, this and this. So we have surely covered these 2 options, and in this option there are 2 options: is remainder even, or remaining moves are odd. If they are even, then yes, answer will be yes, then no. Now I have covered all the possible outcomes, and I have done the code in the same way. See, in this for loop I am calculating that what will be the final coordinates for Alice by increasing and decreasing xa and ya. So at the end I will be remaining with the final position of Alice with xa and ya. Now here I am finding the absolute difference, and also I am using the absolute function so that I can get absolute difference. And I think that code has not, complete code is not there. Let me try to paste it again. Where it gone? Let me write it. Let me write the remaining code. So here I have calculated the differences x and y, and here I have calculated the total difference. Now I have told you that this is the condition when I am saying yes. This is the same condition when n is equals to d. And in the other option I will check if n is less than d in else condition. So in else condition I will check if n is lesser than d, then I straight away I will print no. And in that else I will again check if these 2 conditions are not true, then surely this will hold true. And I will check the remaining number of moves that are remaining with us, and we'll check if it is odd or even. If it is even, then we will print yes. If it is odd, then simply will print no. That's it. This is the explanation of this problem. If you like the explanation, you can consider subscribing my channel, and we'll meet in the next video. Thank you.